Alright, Miss Figueroa here. Now we're doing inequalities, so single variable inequalities. So we should be familiar with what these symbols mean from before. If there is a line underneath, then these are going to be my or equal to's. So here, this first one is greater than. And now we add or equal to. Here on the right, we've got less than or equal to. And then on this right side of that line that I drew, we've got less than and greater than. So we're going to draw a graph for both of these inequalities. So n is less than or equal to -5. So I'm going to find -5 right here. Draw my starting point. Because this is or equal to, whenever there's a line, that means it's a closed circle. So this is closed. And then less than, we're going to go to the left. So everything over here. Then on number 2, we have n is less than 5. So I'm going to go to 5. Sorry, less than or equal to. It has a line underneath, so closed circle. And again, less than means to the left. So everything to the left of this point is colored in. Then write an inequality for each graph. So we're going to say n, like those 2 examples we're using. N is, and in comparison to in comparison to 5, I'm sorry. In comparison to 5, n is going to be to the left. So it is a less than, closed circle, so or equal to, and then that point we're on is 5. Number 4, this point that I'm at is -1. So n in comparison to -1 is to the left, and it is an open circle. So whenever there's nothing underneath that is an open circle, so n is less than, because we're going to the left, of -1. So n is less than -1. So when we're solving single variable inequalities, we're going to apply what we already know about solving equations to solve our inequalities. So if we have to distribute, we'll do that first. We'll combine, I should say like terms. On the same side of the equal sign, move all variables to one side. And then move all constants to one side. Multiply or divide if we need to, and then simplify. So this is a new rule that we don't have to do when we are solving equations. When we multiply or divide by a negative number, we have to flip the inequality. So if it was less than, now it's going to be greater than. If it was greater than, now it's going to be less than. So we're just going to change it to the opposite. But that's only when we're dividing by a negative number, so that won't be the case every single time. So on these, we're going to solve the inequality and graph the solution. So the first one we have is y plus a -2 is less than 6. So plus a -2 is the same thing as saying y minus 2. So that's the same thing. Y minus 2 is less than 6. I want to get my constants on one side, my variables on the other. So I'm going to move this constant over. I'm going to get y. This comes down just like an equal sign would, is less than 6 plus 2, which is 8. I did not divide by a negative, so nothing has to change. This is where I stop. So y is less than 8. I'm going to find 0. Say that this is 8 less than means to the left. So here I have a circle. There's no line underneath, so that means it's going to be open to the left. So open circle on 8, and then everything shaded to the left. The next one says negative 8p is greater than negative 32. I want to get p by itself, so I'm going to solve it the same way I would solve an equation, by getting rid of that coefficient. So I'm going to divide it out, p, and this is one of those special cases where we have to flip the inequality sign. So because I divided by a negative, I have to flip this sign. So instead of writing greater than, I'm going to write less than. So p is less than 32 divided by negative 8. Negative 32 divided by negative 8 is a positive 4. So p is less than 4. So 0, we'll see that this is 4. Draw my circle there. This should be open because it doesn't have the line underneath. So open circle on 4, and it is less than, so it's everything to the left. All right, on our next example, 12 plus 3a is greater than or equal to 18. So here's my variable. This is what I want to isolate. So first thing I'm going to do is get rid of any constants on the same side. So I need to move that 12 to the other side. I'm going to do the opposite operation, and I'm going to get negative 12, so minus 12, and I get 3a still on the left, greater than or equal to 18 minus 12 is 6. I still need to get a isolated, so I'll divide out that coefficient, and I get a. I did not divide by a negative, so I do not flip the sign. It's only when you divide by a negative number or multiply. So a is greater than or equal to 6 divided by 3, which is 2. So here's my 0. We'll say 2 is here. Draw my circle. There is a line underneath, so this is closed. So closed circle on 2, and greater than, it's not as nice looking as when you do less than left, but greater than means to the right. So I'm going to go to the right of 2 and fill that in. Now on number 4, I see parentheses, 2 terms, and a number on the outside. So I've got to distribute. So I'm going to distribute that negative 3. So negative 3 times x is negative 3x. Remember, we got to make sure we go all the way. So negative 3 times negative 5, positive 15. And that is less than or equal to negative 20. So I want to isolate this x. First thing, move my constants to the other side. Get negative 3x is less than or equal to negative 20 minus 15 is negative 35. And then I need to divide out that coefficient. So I'm going to divide by negative 3. And I get x. This symbol has to flip because this is a negative. So it's greater than or equal to 35 over 3. I didn't circle this one. So 35 over 3 is approximately 11.667. So we'll go to 0. We'll say that this is 11.667. Well, let's write it exactly. We'll say that this is 35 over 3. Put my circle on it. It is greater than, so I'm going to the right, and it has a line underneath. So a line underneath means I'm going to have a closed circle to the right. So I'm shading to the right with a closed circle on 35 over 3. Oops. So now let's do a couple more. 2x minus 5 is less than 18. So I'm going to get that constant out of here. So I get 2x is less than 18 plus 5, 23. Divide by 2. X is, we didn't divide by a negative, so the sign stays the same, less than 23 over 2, which is going to be a little bit more than 11. So we've got 0. We've got 23 over 2. Draw our circle. There's no line underneath, so it's going to be open. It is less than, so we're shading to the left of that number. So everything to the left of 23 over 2 is shaded in. Then on number 2, we got b over 13 is greater than 2. So I want to get this b by itself. So b over 13 is the same thing as saying b divided by 13. So I'm going to multiply both sides by 13. So these two cancel. We get b is greater than, and then 2 times 13, 26. It's isolated already. b is greater than 26. So we'll say 0's over here. 26 is way over here. Draw our circle on it. There's no line underneath, so I'm not filling in that circle. And then it is greater than 26. So greater than, we go to the right of the number. So everything to the right of 26 will be in the shaded region. Now number 3, almost called it number 5. Number 3, we're going to distribute this 5 first. 5 times 2z gives me 10z. 5 times negative 1 is negative 5. I keep hitting the brightness. And that is greater than or equal to, give it a second, greater than or equal to 9. So 10z minus 5, greater than or equal to 9. I'm trying to isolate that 5, so not 5, that z, sorry. So I'm going to get rid of that 5. 10z equals 9 plus 5 equals, where did that come from? Greater than or equal to 9 plus 5, 14. Need to get z by itself, so I'm going to divide out that coefficient. and I get z. We did not divide by a negative, so greater than or equal to 14 divided by 10, which is a good clean decimal of 1.4. So on my number line, I have 0, 1, say 2 is over here, that's not equally spaced. This is 1, 2, 3, there we go. So 1.4 would be here. There is a line underneath, so that means it's going to be closed. So closed circle right on 1.4, and it is greater than, so everything to the right of our circle. And this was my final answer here. Then on number 4, we're distributing this 1.2. So make sure I give y'all the right numbers. 1.2 times -3, -3.6x. Make sure we're keeping that variable in there. Then 1.2 times 5 is 6. Less than or equal to 4.6. So now we're going to isolate our variable, getting rid of that constant first. -3.6x less than or equal to, we subtracted, we didn't divide by a negative, so be careful with that. Then 4.6 minus 6, get -1.4. And then I need to divide out that coefficient. So I'm going to divide by -3.6. Those two cancel. And x is, flip the sign because we've got a negative, greater than or equal to 1.4 divided by 3.6, since they're both negative. It's going to give me a positive 0.3889. So then on my number line, we'll go 0, 1, and we'll say it's way over here. I'm going to make a closed circle right on it, and it's greater than, so everything to the right of 0.3889, which is not exact, but I don't have a calculator, so 0.3889 will do. Now number 5, we have what is a possible solution to the inequality 3x minus 5 is less than 16. So when you're given something like this, the easiest way to see if it is a possible solution is to plug that number straight in. So on A, we're going to plug in 12. So we have 3 times 12 minus 5, and we want to test if that is less than 16. So 3 times 12 is 36 minus 5. We want to know if that's less than 16. 36 minus 5 is 31. Is 31 less than 16? No, it's a much larger number. So A cannot be our answer. Now let's try B. We're going to plug in a 10. So 3 times 10 minus 5 less than 16. Is that a true statement? We have 30 minus 5. Is that less than 16? 30 minus 5 is 25. Is 25 less than 16? No. So B is not our answer. Number 7. 3 times 7 minus 5. Is that less than 16? 3 times 7 gives me 21 minus 5, less than 16. 21 minus 5 gives me exactly 16. Is 16 less than 16? No. It would have to be or equal to, because 16 equals 16. But 16 can't be less than 16, because if we're looking at a number line, is 16 going to be to the left or to the right of 16? Neither. It's going to be right on 16. So C is not our answer. And let's test D. So 3 times negative 1 minus 5, is that less than 16? 3 times negative 1 is negative 3 minus 5, less than 16. Negative 3 minus 5, we're getting more negatives, so that's negative 8. Is negative 8 less than 16? Yeah. So in our solution set, we would have negative 1. Another way that we could solve this would be to solve that. So 3x minus 5, 16, we're going to solve the inequality. So I would add 5 to both sides. We get 3x is less than 16 plus 5, 21. Divide by 3. Mark out that 3. And x would have to be less than 7. So any of our answer choices would have to fall under x is less than 7. This does not work because x would have to be less than, not less than or equal to. So we see that 12 is greater than 7. 10 is greater than 7. 7 equals 7. And negative 1 is less than 7. So the only one that makes sense is D. So then on number 6, we're going to try this one only going the second way that we did this. So what is not a possible solution to the inequality? X minus 3 is less than or equal to, greater than or equal to 5. So which is not a possibility. So we're going to go ahead and solve this. X minus 3 is greater than or equal to 5. I want to get x by itself, so I'm going to move that constant. So x is greater than or equal to 5 plus 3 is 8. So I need my answer to be greater than or equal to 8. Is 15 greater than or equal to 8? Yeah. Is 8 greater than or equal to 8? Yes, because we have that or equal to, that's saving us right there. Is 6 greater than or equal to 8? Nope. 6 is less than 8. Is 8.1 greater than or equal to 8? Yeah, it's a little bit bigger. So our answer, since it says which is not a possible solution, is C, since 6 is less than 8. So then for your homework, you're going to be doing this page here, the solving 1 and 2-step inequalities worksheet. So this is your Tuesday homework. So then go ahead and post that to Canvas when you're done with your completed notes as well.